Okay, today we are moving to section 4. Section 4 is measures of central tendency and variation, and this is the last section of this chapter. So far we have talked about how to collect the data, how to first one was how to formulate the question. Once you have formulated the question, you can collect the data, right? We have talked about how to collect the data, and we also talked about how to analyze the data, and we talked about how to interpret the data too. So last time we overviewed a lot of different displaying data techniques, like a lot of different graphs. So I want you to know how to represent the data in different graphs. You need to know when you're gonna use the specific data. Okay, and today in this section we're gonna talk about the central tendency. In other words, it is center. Okay, so like mean, median, and mode. You are more familiar with those three terms, right? So we're gonna briefly talk about that, and I'm gonna teach you how to find each of them. And then we're gonna move on to variation. Variation is about spread, how wide the data is spreading. So we're gonna talk about those. This section is very lengthy. There are a lot of things that we have to talk about. It's not hard though. Okay, once you know the formula and how understand what that means, you should be able to find, or the data set for the center or variation. So the first thing is the measures of central tendency or center. Of course, there are mean, median, and mode. In contrast to the center, we're going to talk about spread. Spread includes range, variance, deviation, and standard deviation. So after we talk about central tendency, we're going to move to spread. Do you hear the noise here? This is from my office. I asked for fixing it, and they said they did, but around like this time of the day, it happens again. So I think my room is haunted. Okay, anyways, the mean. We know how to find the mean, right? We're gonna add all of the values together and divide it by the number of the data. That is the mean, right? So arithmetic mean is number commonly used to characterize a set of data. For example, we can find our average score in our test, something like that. So frequently we call mean as average, or sometimes we call that as mean. So when we're talking about average, it's the same as mean. You can find the sum of the scores in each case and divide that by the number of scores. Right, so here is the definition. The arithmetic mean of the numbers x1, x2, all the way to xn, denoted as x bar. X bar is mean of the sample data. Okay, when you are having statistics more in depth, you're gonna have mu. You don't have to know that now. That is for population mean, but now we are only talking about our sample data, so only the collected data we're gonna deal with. That's why we are using x bar instead of a mu. Okay, so x bar can be found as sum S-U-M, sum of the data values. So you're gonna add all the scores together and divide it by how many are there, n many. 1 through n. There are n many, so you're going to divide it by n. For example, in Mr. Smith's class, the scores were 62, 94, 95, 98, and 98. In Mr. Smith, let's say in Mr. Smith's class, you have scored first test as 62, second test as 94, third test 95, fourth 98, fifth test you got 98. What is your average in Mr. Smith's class? How do you find it? You can add these together. You're gonna find the sum of these 1, 2, 3, 4, 5 values. Then you're gonna get 447, and then you're gonna divide that by how many tests were there? 5 divided by 5. Okay, so this is your mean score of the test in Mr. Smith's class. So that's how you find the mean. And what is the meaning of the mean? I have put the balance points here. So mean you can think about this as balancing out. So for example, let me make it smaller because I cannot move these dots around here. Sorry that it doesn't look so big, but I can move easily. So we can think about moving the dots in the center, and you're gonna see where all the dots line up. So for example, here this can move to 1 up, then you can move this to 1 below, then move this to the up here, then move this below, and move this up, oopsie, and move this down. We're gonna keep doing this until we have only one variable, one value. Keep going on and on and on, up and down and up and down and up and down. You can already predict where all these dots go, right? So up here and down below. Then all the dots are on 3. So we can see that, 3 is the balancing point. So that is your data. So if I go back, this was the original, I believe. Yeah, this was the original. Okay, and here we had a lot of variables that are spread out. But after we balancing them out by moving one down, one up, and so on, we moved all the red dots here above 3. So we get to know 3 is the average. That's the mean. Okay, or you can do it this way too. 1 plus 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 5 plus 5 plus 7 divided by how many dots are there? 10, so divided by 10 and you get 3. Okay, all right, so let's move on to the medians. So we learned how to find the mean. To find the mean, you can just add all the values together and divide it by the number of the data. Okay, median is a little bit different. It's still the center. But median, to find the median, you're gonna find the value exactly in the middle of an ordered set of numbers. Okay, we're gonna have some examples there. So to find the mean, what you need to do first is you need to rearrange the scores either in increasing order or decreasing order. And you're gonna find what is in the middle. Okay, so for example, here are the values: 62, 94, 95, 98, 99, 98. These numbers are from the previous example. Okay, the test score of yours in Mr. Smith's class. We can rearrange this into increasing order from smallest to the largest, right? And we're gonna see this is not the middle, 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 this is the middle, right? This is the data, the value exactly in the middle of this ordered set of data. So below 95, we know these values are less than the median, and these scores on the other side, their values are greater than the median, right? When you have odd number of scores like this, we have 1, 2, 3, 4, 5, then the median is exactly right in the middle. So it's evening out. You have exactly same value on the other side and the opposite side. What if you are given even number of scores like this? So you have 6 different values. Then, well, of course, first and last, second from the first and second from the last, they are out, but what is in the middle is actually 2 values. Then the median can be found as the mean of these 2 values. So find the average of 70 and 74. How do you find the average of 2 values? You add them together and divide it by 2. So that is your median for even number of scores. Okay, and I have marked here often reported with the interquartile range. So later we're gonna talk about interquartile range. To find the interquartile range, median is heavily used, and we indicate that as Q2. Okay, Q2, quartile, second quartile, because it's right in the middle, 50%. The first quartile should be 25%, and the third quartile will be 75%. So we're gonna talk about that a little bit. But to find that interquartile range, you're gonna use the median. Just remember that one now. And the third center is mode. What is the mode? Mode is the value that occurs the most frequently in your data set. So for example, in this data set, we know 62 occurs only once, 94 only once, 95 only once, but 98 occurred twice. So 98 is the mode, right? Okay, so mode is 98. How about in this data set? 65, 75, 64, 75, 75, 82, 90, 90, and 98. So you can see 75 occurs twice, and 90 also occurs twice. So 75 and 90, both of these 2 values are the modes. So we have 2 modes. What do we call that? We call that bimodal. So there are 2, both of these are the modes. Okay, 75 and 90 are bimodal. Okay, and I want you to pause this video to find the mean, median, and modes for this data. Pause the video and make sure you find mean, median, and the mode. How do you find the mean? Mean can be found as sum of these 1, 2, 3, 4, 5, 6 values divided by 6. So you get 80. Yes. What is the median? It is already in ascending order, and you can see it's an even number. So the 2 values right in the middle, and you need to find the average of these 2. So add these together, 70 plus 95 divided by 2, and you get 82.5. That is the median. What is the mode? What occurred most frequently? 60 is occurring twice, and 95 is also occurring twice. So this is also bimodal, and the modes are 60 and 95. So I have a solution here. This note, you can find it under resources, under class notes. Okay. So we have learned about 3 different types of measures of central tendency. Although the mean is commonly used to describe a set of data, it may not always be the most appropriate choice. For example, suppose a company employs 20 people. The president of the company earns $200,000. The vice president earns $75,000. Oh, big difference. And 18 part-time employees earn only $10,000 each. So very low, right? So there's a big gap between the president's salary and 18 part-time employees' salary. It's a big gap. Do Do you think the mean is the best number to choose to represent the average salary for the company? So let's compare. Let's calculate the mean. The mean salary for this company can be calculated as 200,000 plus 75,000 plus 18 part-time employees earns 10,000. So 18 times 10,000. Divided by, the sum divided by how many are there? 18, 19, vice president, and president, 20. So there are 20 people. So sum of these values is 455,000, and you can divide it by 20 to find the mean, and you get 22,750. Look at this price. Do you think this is very representative as the center? I would say no, because it's very, very far away from how much the part-time majority of people there, part-time 18 part-time employees earn, right? So I would say the mean is not very representative. How about median and mode? The median is 10,000, because think about 20 people, what is in the middle? One of these 18 part-time employees. Yeah, it sounds more like it, because majority of the people, so out of 20, 18, what is the percentage of 18 out of 20? So 18 divided by 20, it's 90%. So 90% of people here earns only $10,000. You cannot say the mean is the center, right? But the median is 10,000, and the mode is also 10,000. So either mode or median should be very representative as the center here in this case. So yeah, as we have seen in this example, we know mean is not always the best option to represent as the center of the data. Okay, sometimes mode is the best way, and sometimes sometimes the median is. Okay, so let's look at more examples. Suppose 9 students make the following scores on a test: 30, 35, 40, 40, 92, 92, 93, 98, and 99. Is the median the appropriate average to represent the set of scores? So do you think the average is a good measure to find the center? What is the median? This is already arranged as ascending order, right? So we can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Half of that is 4.5. So the value, the median should be between 4 and 5. Fourth and fifth number. 1, 2, 3, 4. This is the fourth number, or 4.5. So between 4 and 6. And this number here, because it's 9, exactly in the middle number is the median. So 92 is the median. Do you think 92 represent the set of scores here? What do you think? I don't think it does, because take a look. 92 is very close to the upper scores. So when you're looking at the scores in the below the mode at the median and above the median, there's a big difference, right? So these scores, this group of scores here is very, very low, but the other score on the other end, their scores are so high. So if we say 92 to make it represent the total score, I think there's too much gap between this and these 4 values. So I would say median is not really good. Then we can consider what could be the good measure to represent the set of data. How about the mean? When you're adding this sum and divide it by 9, you're gonna get about 69. Do you think that is a good number to represent this? 69 is still very far from these values, right? And it's also far away from these values too. So let's consider then mode. What is the mode here? I see 40 twice and 92 twice. So it's actually bimodal, but 40 and 92. 40 is very representative of these group of values, and 92 can represent the other group, right? So I would say, yeah, the modes 40 and 92 can be more appropriate to represent this set of scores. Okay, and let's think about next example. How about the mode for this set of data? Do you think the mode is appropriate average for the following test scores? What is the mode? Let's see, 40, 42, 50, 62, 63, 65, 98, and 98. 98 is the mode in this set of score. However, as you can see, 98 is not very representative of the set of data because it only represents upper part here, right? So it doesn't represent any values that is below 98. So I would say, no, not really, it's not good. So I always want you to consider which is the best center to represent the total data. Okay, now we're gonna move on to measure of spread. So center was pretty easy, I guess. You just need to know what that means, each of mean, median, and mode, and you need to also know how to find that. Measure of spread. To find the measure of spread, you need to understand what that means. It's asking you how varied the values are, so how far away each values are from the other. Okay, so the first thing we can talk about is the range. The range is basic statistic that tells you the range of values. For example, you can find the minimum and the maximum of the values. If the maximum is 100 and minimum is $10, then the range is the difference between those two. So 100 minus 10. So you can find the range as maximum minus minimum. Okay, range is maximum value minus minimum value. A similar statistic is the interquartile range. When we were talking about median, I briefly talked about interquartile range, right? Interquartile range, which tells you the range in the middle 50%. So range, we are covering 100% of the value from minimum to maximum. But interquartile range, we are only talking about the middle 50%. Okay, in other words, it's where the majority bulk of data tends to lie. So I want you to consider this following set of test scores: 20, 25, 40, 50, 50, 60, 75, 75, 80, 80, 90, 100, 100. How many data are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's odd number of data, so you can find the median easily, right? So right in the middle is right here. You can cross out the first, second, third from the bottom and from the top, fourth, fifth, cross out, fifth, sixth, and then 70 is right in the middle. So we know this is median. Median is interquartile in the interquartile range is Q2, second quartile, because it shows a 50%. First quartile, in other words, is lower quartile is 25%. So let me actually show you this. This really helps you. So we know 70 is the median, which is Q2, then what is the first quartile? You're gonna find the median of lower part, lower half. So among the lower half, there are 6 different values. Because you have even number of values, you can find what is in the middle as average of these two values. So average of 40 and 50 is 45. That is lower quartile, Q1. Similarly, upper quartile, Q3, is the average. The median of the upper part. Okay, so median of the upper part is right here, the mean of 80 and 90, which is 85. That is upper quartile, Q3. Okay, so once you find Q1 and Q3, you can find the difference of those two. So IQR, interquartile range, is Q3 minus Q1. So we're just gonna look at middle 50% here. Okay, so 85 minus 45, Q3 minus Q1 is interquartile range. Okay, so let's look at these prompts that I gave you. What is the range? Range is maximum minus minimum. Maximum value is 100, minimum value is 20. So the range is 100 minus 20, which is 80. To find interquartile range, first find the median. Without knowing median, you cannot find the 25%. So find 50% first, which is the median, Q2. Once you find it, you can find another median in the lower half. So you can find the Q1, and you can take a look at the upper 50%. What is half of median of that? So you can find Q3 there, which is the 75th percentile. Once you find that, you can find the difference between Q3 and Q1. That is IQR. In our example, 85 minus 45 is interquartile range. So interquartile range is 40. Okay. So in the homework problems, you're gonna do a lot more examples there. Okay, let's move on to box plots. A box and whisker plot, sometimes it's called as a box plot, displays the 5-number summary of a set of data. 5-number summary. What are the 5-number summary? Very important numbers that we can get from our data. The minimum, we need to know the minimum, and the maximum, of course. What are the other three? Q1, Q2, Q3. Q1, 25th percentile, median, which is Q2, which is 50% percentile, 50 percentile, and Q3, 75th percentile. Okay, so the 5-number summary includes minimum, Q1, median, Q3, and maximum. So in box plots, you're gonna show these 5-number summary. Then you're gonna see where your data are. You can see your data range from minimum to maximum, and majority, the half of the values are here and others are here. So you can see some outliers, and how the data are scattered together, scattered or clustered together, things like that. Okay, so in a box plot, you need to have a Q1, Q2, Q3. They are in the box, and others are in the whiskers. So that's why it's called the box and whisker plot, or just total, we just call that as box plot. Okay, so the whiskers go from Q1 to the minimum and Q3 to the maximum. Okay, that is box plot. Let's practice to make the box plots using this example. Actually, I want to open my Jamboard. Okay, so in this example, a sample of 10 boxes of raisins have these weights in grams: 25, 28, 29, 29, 30, 34, 35, 35, 37, and 38. You need to make a box plot of the data. Okay, so the first step you need to do is you need to see whether this is in the right order, whether it's increasing or decreasing. So let's take a look at that. It's already in increasing order, so we are good. Now, second step, so let me write that first. Okay, first step, step 1, you need to order the data from smallest to largest. I have this in your class notes too, so if you don't like my handwriting, is there ugly? You can refer to that one, okay? Second, what you need to do is you're gonna find the median. So let's find the median. I actually wanna use this color. Okay, so find median. It's Q2 in other words. So median is, you can find it this way: first, second, cross them out, third, fourth, fifth, in between these two, right? So what is the median? Median is average mean of these two values, 30 and 34, divided by 2. 64 divided by 2, 32. So we found Q2. Then next, what you need to do is you need to find the Q1 and Q3, right? The other quartiles. So find Q1 and Q2. I mean Q3. You already have a Q2. Q1. So second, in the median is right here. That's Q2. Okay. To find Q1, you need to look at the lower part of the data. What is the median in this lower part? We see that 29 is in the middle. So that is the median, and that is then Q1, 25th percentile. How about Q3? You're going to look at the upper half. What is the median in the upper half? 35 is, right? So that is Q3. So we found Q1 as 29 and Q3 as 35. Then next step that you need to do is you're gonna find the 5 summary. So 5 number summary, consider that 5 number summary. We already found most of the needed numbers, right? So 5 number summary is, you're gonna find minimum. What is minimum? The lowest number, 25. What is Q1? 29. What is Q2 or median? 32. What is Q3? 35. Last one. What is the maximum? 38. So once you know all of these numbers, we can use it. Okay, so how do we use these values? Let me have these numbers. 25. Write this down on your notebook so you can easily transfer that to the box plot. Okay, I have that here. Okay, so now with those number summary, let me rewrite that. Minimum, well, I'll just say 5 number summary. We have 25, 29, 32, 35, and 38 in order. So we know this is minimum, Q1, median, Q3, and the maximum. We know that. Knowing that, we can make the box plot. So when you're making box plot using the 5 number summary, you can draw a line and scale that. So what is the minimum? 25. And all the way to 38. Right? Okay. So I'm just gonna go in the equal scale here. 25, 26, 27, 28, 29. I will just mark it here. 29, 30, 31, 32, 32, 33, 34, 35, 35. Oops. 33, 34, 35. This is 35. 36, 37, 38. So I marked the important numbers here: 25, 29, 32, 35, and 38. Let me use different colors because of that mistake. Sorry about that. Okay, so now we know from the minimum to the Q1, it's whisker. That's whisker. And from 29 to Q3, Q1 through Q3 is in the box. And from Q3 to the maximum is another whisker. And we have median here. So this yellow part is the final product of this box plot. Okay, we have whiskers here. And without writing this is minimum, this is Q1, Q2, Q3, Q2, Q3, and maximum, we know that this is minimum, and so on and so on and so on, right? Okay, so you don't have to label that anymore once you have that. Sometimes, like me, I like to mark whisker here and box plots right on the number line. Some people like to have it above the number line. So if you look at my note, this box plot is right above the number line. So for example, in the class notes, you can see 25, 29. Of course, there are scales here. I'm just omitting all the scales that I have there. Okay, 29, 32, 35, and 38. If you have numbers, 5 number summary there, you can draw it above it. Okay, draw the box plot right above it. But what you need to be careful is you need to line up, this whisker starts from the minimum, ends at Q1, 29, and Q2 median is right above 32, Q3 is right above 35, and 38, the maximum is right above 38. So you need to line that up, okay? And sometimes, a lot of times, we are using this as that, like that. So I'm pretty sure you are able to make this box plot, okay? And we need to talk about how to interpret the quartiles. So using the 5 number summary, the 5 number summaries show, each different sections. So we know that this is 50% in the total, and this is 25%. Then how much is this this much? That's also 25%. So when we are talking about values down here between 25 and 29, that's 25% of the total values. And also from here to there is 25%, and that's 25%. And from here to Q3 to the maximum, that there are 25%, because we distributed the data equally. The same amount of data are in each of these, right? So we can see that Oh, that's 25 percentile, that's 50 percentile, that makes 70 percentile, and the total is 100 percentile. Okay, so let's go back here and let me ask you some questions. When you're looking at this example, about what percent of the boxes of raisins weighed more than 29 grams? So I can actually use mine here. Okay, so question is, about what percent of the boxes of raisins weighed more than 29 grams? So let's look at 29 gram here. Let me use different color. 29 gram is right here, right? And I was asking what percent of the boxes of raisins weighed more than 29 gram? More than 29 gram. All of my data are here above 29 gram except 25%, right? So we know there are 75% of the raisins weighed more than 29 gram. Okay, that's how you interpret that. Then how many percent, what percent of the boxes of raisins weighed less than 29 grams? You can see that 25% of the boxes of raisins weighed less than 29 grams. So you can vary, the questions like that. You can also ask, what percent of the boxes of raisins weighed more than 35 grams? More than 35 grams, it's only 25%. Okay, so hopefully you know how to interpret that data. Let's have one more example there. What are the minimum and maximum values, the median and the lower and upper quartiles of the data set whose box plot is shown here? Well, it's exactly 5 number summary, isn't it? So we know that this is a minimum. Minimum is 0. Q1, the first quartile is 10. And what is this? Median, Q2 is 20. What is this? Q3, the third quartile, that's in between 30 and 40, exactly in half, so 35, right? And what is this? That is the maximum. So we can find all of those values. Maximum is 70. So minimum is 0, maximum value is 70, the median is 20, lower quartile is 10, upper quartile is 35. Okay? Okay. This video is a little bit lengthy because we have to talk a lot about central tendency and the variation. We are still working on the variation, spread here. Okay, so the outliers, we have 3 more slides for part 1. Part 2 will follow next. Okay, but outliers, you already know what that means, right? An outlier is a value widely separated from the rest of the the data. So in a set of scores such as 21, 92, 92, 93, 93, 93, 95, and 150, take a look at this. You can suspect some values very far away from the rest of it. Like 21, it's very far away from 90s here. And 150 is also very far away from 90s here. So maybe you can suspect that 21 and 150 might be the outlier, right? We're gonna talk about how to determine the outlier a little bit later. Okay. So we call that potential outliers, but we're not so sure whether they are actual outliers yet. Okay, the upper and lower extreme values are not necessarily outliers. Sometimes, like this one, 75 and 93, yeah, easily we can say that, well, maybe 75 is, but I'm not so sure. So how can we decide the outlier? Outlier is any value that is more than 1.5 times the interquartile range IQR, Q3 minus Q1. Okay, above the upper quartile or below the lower quartile. Statisticians sometimes use values different from 1.5 to determine outliers, but here we're just gonna use 1.5. Okay, so if your value is 1.5 times interquartile range above or below above upper quartile or below lower quartile, then we consider that as outlier. Okay, we're gonna do some practices on that. It is common practice to indicate outliers in box plots with asterisk. Okay, all the values are in the box plot because we are showing minimum through maximum, right? But some values, any outliers, we put stars above it. So whiskers are then drawn to the extreme points that are not outliers. Okay, so we're gonna do a little bit of the practice here using that values here. So using this, I'm not gonna do the whole process because we already have talked about how to draw the box plots. Okay, so you know how to find the minimum. Minimum is 11. We have 10 down here, so let me move the cursor here so you can take a look at that. You see the criteria 10 number of medals for top 20 countries in 2016 Summer Olympics. In United States, we had 121. That is the maximum. So we have two numbers. We need 3 more. The median is 21.5 because that's right in the middle. This is in the descending order. From the bottom, it's ascending order to the top. Q3 is 42. So you found the Q1 and Q3. Then you can find interquartile range. IQR is Q3 minus Q1. 42 minus 16. What's 42 minus 16? 42 minus 16 is 26. So 26 times 1.5 is what you need to find. Actually, let me open the Jamboard for you. Okay, so draw a box plot of the data in table 14. So we know this is maximum, minimum, Q3, median, and Q1. You know how to find all of that, right? And we are concerning about how to find the outlier. Okay, so to find the outlier, what you need to do is you need to find the interquartile range. Interquartile range. How do we find IQR? It's Q3 minus Q1. What is Q3? 42. What is Q1? 16. So subtract 16 from 42, and what do you get? You get 26. Okay. Now, to find the outliers, what you need to do is you're gonna do 1.5 times interquartile range. You're gonna find that. Okay, after you find the interquartile range, find what's 1.5 times IQR. 1.5 times IQR. IQR is 26. Times 1 is 26, half of that is 13, so 26 plus 13 is 39. That's 39. So you need to look at what value is lower than Q1 minus 1.5 IQR, and you need to know, you need to find what value is bigger than Q3 plus 1.5 IQR. Those values that fall into these categories are the outliers. So Q1 is 16. 16 minus 39. You don't even have to do this because it's already negative number. Negative number, there's no negative number. The minimum is 10. So there's no outlier on the left hand side of the median. How about here? How about on the other side of the whisker? Q3 is 42. 42 plus 1.5 times interquartile range, 39. And you get 70, 80, 81. That's 81. So you can see, oh, United States of America, that value, 121, is way bigger than 81. So that is the outlier. There's no outlier on the left hand side, but on the right hand side of the whisker, you have the outlier. Okay, because we found that from Q3 plus 1.5 IQR. So when you are drawing the box plots, we can mark it from 10, or you can do it from 0, but it doesn't matter. 10. I'm gonna go by tens because we have such big values there. 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. This is 120. And I see 10 is the minimum. 121, very close to 120, that's the maximum. And we have Q1, 16. This is 10, this is 20. So 16 is about here, a little more than half of that. Right? So I can start from, like textbook, I can draw it above. So there's a whisker. So you can see that it's not very far from, this 50% of the groups. So you can already feel that there's no outlier on this left hand side, right? And your Q2 is 21.5. 20 is here, so 21.5 is very close to 20. And Q3 is 42, so very close to 40. And here is the box. Here is the box. Okay? And the whisker goes all the way there. So you can already see that, oh, it's very, very far away from the rest of the data. Okay? And what did we say about the outlier? We can mark it with asterisk. So instead of a dot, you can put that as asterisk. Start there. Then we get to know, oh, that value is the outlier. Okay? So that's what it is, and I have one more thing to talk about before I close up. So when you're comparing sets of data, not only one set of data, but when you have more than one set of data, for example, you have fuel economy of 2017 compact cars and medium-sized car and large cars. So you're gonna compare the fuel economy. Which one has the best, the fuel, maybe like gas mileage, okay? Then you can make a table like this. And for each of these cars, compact cars, medium-sized car, large cars, you can have 5 numbers, right? 5 number summary, maximum, Q3, median, Q1, minimum, and make a box plot. Make box plot for each. For large car, you have a box plot there. Second, medium size, you have a box plot there. Third, you have a box plot there. And then you're going to interpret that. So by comparing these 3 box plots, how would you interpret that? From the box plots, we see that the median gas mileage for compacts, look at the medians. What do you see? Median gas mileage for the compact cars is higher than the rest of the other two, right? So this data for large cars are less spread. Take a look. The spread is only from here to there for large cars. But for compact cars, there's a bigger spread, right? So even though we cannot spot clusters or gaps in box plots as we can with stem and leaf or line plots, we can more easily compare data from different sets, don't you think? I think so. With box plots, we do not need to have sets of data that are approximately the same size as we did, for back-to-back stem and leaf plots, right? It's different. To compare data from two or more sets using their box plots, we first study the boxes to see whether they are located in approximately the same places. So we can compare the medians. We can compare, the IQR there. Next, we can consider the length of the boxes to see whether the variability of the data is about the same. So we compared the range there. Well, it has less range than the other two. We also check whether the median or the quartiles and the extreme values in one set are greater than those in the other two sets. If they are, the data are greater than those of the other set, no matter how we compare them. If they are not, we can continue to study the data for other similarities and differences. Okay, so hopefully you understood what's going on in the central tendency and the variability, especially using box plots.